Good morning, everyone. Today we are covering the topic appreciation versus depreciation, and we're going to learn the differences between the two, and we're going to be able to calculate the future value of an asset that depreciates in value over time. A quick minds on, when you invest money with a bank, it typically grows over time. I want you to think about some items or investments whose value decreases over time, and why do you think this might be. So I'll let you pause the video right now, think about it, see if you can jot down some notes in that blank space in there, and then come back to the video in a sec. So items that represent very scarce resources, so things like land, housing, any collectible items, paintings, anything antique-y, right? They normally appreciate in value over time because there's less supply of those items. However, things that we consume, so it can be anything that's a household item, cars especially, any electronic appliances, machinery, equipment, fixtures, all of those things lose their value over time because over a period of time they're being used and they're consumed, and they're not in as pristine of a condition as they are when you purchase them. And that's the key difference between the two items. Appreciation is a continuous increase in value of an asset over time. How is it calculated? It's calculated using the same compound interest formula where you're adding interest to the original value, okay? Because it's increasing in value over time. Like I said, some examples that you can include in there are things like housing, land, if you want to add that in there, any collectible items, antique items, etc. Okay. Depreciation is a continuous decrease in the value of an asset over time. The way this is calculated is, again, using the same compound interest formula, but except in this case, since the value of the item is decreasing in value, you would subtract your interest rate, or you would subtract the rate of interest and then raise it to the same amount of period of time, so to the power of n. Some examples here that you could include are cars, furniture, electrical appliances, right? And that includes your phone and any of those items that are considered consumables, okay? The graphs for appreciation, they increase in value exponentially. So if you're looking at money invested in a stock, money invested in a GIC, right? Remember how we talked about that money grows exponentially? So that's what that curved graph looks like. Depreciation is kind of the reverse of that, where it's decreasing exponentially, and over a period of time it almost stabilizes, because if you think about it, whether it's been 8 years or 10 years, it doesn't matter, the value of the car is still pretty low, okay? Let's take a look at an example here. A condo is purchased in September 2018 for $350,000. It appreciates by 1% each month. How many months have passed since September 2018? That's what tells you the value of n. So it tells you how many periods of time you're looking at. In this case, we're looking at it monthly, because if you look at this part here, our interest rate is per month. Okay, so we're going to try and make sure our n, or our compounding periods, are also in months. So since September 2018, you've got September 2019 is a year, 2020 is 2 years, 21 is 3 years, 22 is 4 years. So you've got 4 years and 1 month since we're in October now. And that's essentially equal to 48 months plus that 1 month. That's a total of 49 months. That's what your n value is, okay? So if I were to look for the current value of the condo, I'm essentially asking you for this amount. What is that future amount that we're looking at from the time the condo was purchased? The principal amount is when the condo was purchased, so that borrowing amount that year was $350,000. The interest rate that we're looking at is 1% each month, and that's equal to 0.01. And the number of compounding periods in this case is 49 months. Okay, so if I were to solve this as a formula, you are going to say that's equal to our principal, which is $350,000, times 1 plus I. Why am I adding my interest in this case? Because the value of a condo increases over time. It appreciates. And then you want to do to the power of n. This little hat here, that's essentially the exponent. I just can't write an exponent on my computer for some reason, so just bear with me with that little chapeau, okay? So that's equal to 350,000 times 1.01 to the power of 49. Don't forget to use BEDMAS here. And that's equal to 350,000. You should get times 1.6283. Keep as many decimal places as possible to get the most accurate answer, okay? And then you finally want to multiply the two numbers, and you should get 569,921. So therefore, the value of the condo is now, what was that number? $569,921, okay? And that's an example of appreciating. Very similar to how you do compound interest questions. Just something to remember is your compounding periods should kind of match your interest rate. Now let's take a look at the formula for depreciating, right? The only difference is that negative sign there because the value is going down over time. Everything else stays the same, okay? So this graph on the right here shows the value of a new car from the time it was purchased. If you look at the value, I'm going to try and extrapolate or figure out what that number is where that point is starting off. So that point there is right in between 28,000 and 32,000, and that's going to be 30,000. And that tells you that year zero, it was 30,000, which means the car was purchased at $30,000, right? During what year did the car experience the greatest depreciation? So if you look at this graph here, I'm going to draw a line connecting these dots, and you want to look for the line that has the steepest slope. So what is the most drastic decrease that you're looking at? And you'll notice that the most drastic decrease here is between year zero and year one. So during what year did the car experience the greatest depreciation? I would say year one. Okay, year zero to year one. So over the course of the first year, and that's normally very common. The value of a car drops down by at least 30% the minute the car is taken out of the dealership. That's just very common with cars. By what percentage did the car depreciate in the first year of ownership? So we're going to look at what the value, how much that value has gone down. So it's gone down from 30,000 to this value here is right between 20,000 and 22,000. So I'm going to approximate that to be 21,000, okay? So what percentage did that car drop down? I'm going to take my new value, divide it by the original value, which was 30,000. And then in order to figure out a percentage, you always want to multiply that by 100. So that's going to give you 21,000 divided by 30,000 times 100 is 70%. So 70% is what its current value is at, right? This is 70% of the original value. In order to figure out how much it has depreciated, you want to subtract that from 100%. So 100% minus 70% equals 30%. Therefore, the car has depreciated by 30%, okay? If this doesn't make sense, think about it again. This value here has dropped down to 21,000, and that is 70% of its original value, which means it's dropped or depreciated by 30%. It's gone down by 30%. If the value of the car 2 years after purchase is 16,800, by what percentage did the car depreciate in the second year? All right, so let's take a look at that. We're going to do 16,800 because that's my new value, right? And I'm going to divide that by the value in the first year. So the value in the first year was 21,000. Okay? And then again, you want to multiply by 100 to get your percentage number. So we're going to do 16,800 divided by 21,000 times 100. That's 80%. So 16,000 is 80% of 21,000. 16,800 is 80% of that. So it depreciated by how much? 100 minus 80, which is equal to 20%. So in the second year, it drops down by 20%. So once again, the first year, it was down by 30%. And the second year, it's slightly less. It's decreasing a little bit less, and that slope is a little bit less steep. So that's 20%. And you'll see that gradually it kind of drops down by less and less of a percentage each time until it almost stabilizes, okay? If the car is depreciated on average 25% each year, how much will it be worth after 10 years? This is where you want to use an equation to solve because you're looking at it at a time frame. So we're looking at our initial value, our principal value. That's going to be 30,000 because that's how much I bought the car for. The time period that I'm looking for is 10 years. I'm going to say on average, it drops down by 25%. So my interest rate is 25% each year, which is 0.25, okay? How much is this worth in 10 years? You want to use your formula, so P brackets 1 minus your interest rate to the power of n. And that's going to be equal to your principal, which is 30,000, times 1 minus that 0.25 to the power of 10 years. Again, that's equal to 30,000. 1 minus 0.25 is 0.75 to the power of 10. Remember, we're using BEDMAS, so solve what's in brackets first. Then we're going to solve our exponent. So we're going to do 0.75 to the power of 10, which is 0.0563. And then you want to multiply that out, and that's going to give you 1,689.41. Okay? So therefore, after 10 years, the value of the car is $1,689.10, which makes sense. It has to be a much smaller number because the value of the car drops down quite a bit. And it also kind of aligns with that graph that we're looking at, because it's going to keep going down, down to below 4,000. By the time it's 10 years, it should be less than 1,000. Okay? Other types of investments that we want to look at. Some investments do not strictly appreciate or depreciate, and a huge example of this is the stock market. So you guys are investing in the company that you're looking at. You can take a look at it. It's been going up and down. It's a little bit volatile. It fluctuates over time. These are riskier, but sometimes they yield a higher return. Very often the stock market can, on average, over the course of 10 years, 11 years, your interest rate can go up by like 10 to 14%. So this is a really good example there, okay? For your homework, you can complete 3.6, whatever practice questions are assigned in your unit outline. The only thing I want to go over is maybe question 3. Try that one out. Which one was it that I wanted? No, question 4. So once again, we're looking at the value of a school bus. It decreases from $512,000 to $343 in 3 years. Find the annual rate of depreciation. Here, you're given your principal, and you're also given your future amount, okay? And you're given your time, which is 3 years. You just need to look for I. And the way you want to do that, remember that you want to start by dividing the future amount by the principal, okay? That's your first step, and then you want to divide that value by 3. That's how I'd go over looking at that. And I can take up some of these questions that you're having trouble with tomorrow. If you have any free time, a couple things that you can work on right now are your homework questions. Complete that. You can work on that bonus budgeting assignment that I gave you yesterday. For the Excel graph, I will bring in computers tomorrow, so you will have an opportunity to complete all of the tech stuff in class tomorrow, okay? And we're going to cover 3.7 in class tomorrow. All right, that pretty much wraps up our lesson. It's pretty quick. Hopefully this made sense. Try and complete all of your homework. If you've got more free time, try and get started on this unit review for the unit. And remember that your test is, not your test, your assignment is on Tuesday. Good luck, guys. See you tomorrow.